Hello and welcome to a Maths with Harry lesson. In this video, we're going to have a look at tangent and chord properties. On screen, we have got two circles and we've got four straight lines. Before we jump into the properties of tangents and chords, let's have a look at what a tangent and a chord actually is. So we'll look at the first circle first. I've got a dashed line here and I've got a red line. Okay, and I'm going to place that red line on the circle about there. Okay, that's where I'm putting my red line, and that red line there is a tangent. Okay, and I'll draw that on in green. I think we covered this in a previous video, but we'll cover it again. Okay, that red line there is a tangent. The reason it is a tangent is because it intersects the circle at just one point, and I'll do it in a pen. It intersects the circle about there, okay, just one point. So that's what a tangent is, okay? Now I can draw on this dashed line as well, and I'm going to place it quite conveniently so that it passes through, and we'll just move that to match up a little bit. We'll just move that there, so that it passes through the centre of the circle, okay? That dashed line there is the radius of the circle, okay? And the reason it's the radius is because it passes through the centre and it goes to this yellow point here, which is on the circumference of the circle, okay? So from the centre to the circumference, it's the radius. So we'll draw that on in green, okay? That there is the radius. However, you might just be able to see by looking at the circle that those two straight lines intersect at a right angle. So let's draw that on as well. There is my right angle. So what that means is that these two lines, the tangent and the radius, are perpendicular. Perpendicular means they meet at a right angle. So the radius and the tangent are perpendicular. So what does that mean? Well, that means that they are perpendicular at the point of intersection, okay? They're not perpendicular here, for example. If I was to move that line just to maybe be at that point there, okay? So that's still the radius, that dashed line, but it doesn't intersect the tangent, okay? So they are just perpendicular at the points of intersection there. Okay, so what we can say about perpendicular lines in terms of gradient is that this gradient, the gradient of the tangent, is the negative reciprocal of the gradient of the radius because they are perpendicular. Okay, and that happens anywhere on the circle. If I was to draw another radius there, for example, okay, that's a radius because, and I'll do it in yellow, because it passes through that point on the circumference and it passes through the centre. So from the centre to that point is the radius, just like this. And then I could also have another tangent like that, okay, or something like that, just intersecting at that point, something like that, okay? Can't get it perfect, but that's also a tangent, okay? And then again, we've got another right angle there. So they would also, of course, because it is a radius and another tangent, they would intersect at a right angle, so they're perpendicular, okay? So there's your tangent properties. Now let's introduce what a chord is. You might not be as familiar with what a chord is. Let's introduce it here. So you can see again, I've got two straight lines. I've got a dashed line and I've got a blue line. We will put this blue line on the circle, not there, because that would make it a tangent. We're going to put it about there. That is a chord, okay? We have 2 points on the circle, and again, I'll do them in yellow. We have a point there, and we have a point, maybe not so big. We have a point there, and we have a point there, okay? Both of those points are on the circumference, and this blue line connects those points together. That makes the blue line a chord, okay? So I will write that on there. That blue line is a chord, okay? So, for example, if we took some other points, let's say we took that point there, and again, we'll take this point again. We could connect those together, and I'll do it in red. Oops. that would also be a chord, okay, because we're connecting 2 points on the circumference together. I could take another point, I'll do it in red, take a point there, connect those 2 points together, that would make it a chord. Or I could connect those 2 points together, and again, this would be a chord, okay? As long as it connects 2 points together. So let's just go back and just have our original chord. I'm then going to introduce this dashed line onto the circle, okay? And I'm going to have it so that it passes through the centre of the circle, okay? This is really important. So again, for this, I'll actually put on that this is the centre of the circle, just so we're really clear, because we can say something quite specific about this dashed line, okay? Now we can see again from our eyes that this dashed line and our chord intersect at a right angle. So we can put that on there, and it's actually true, that's what happens, they intersect at a right angle, okay? And this point here, which I'll do in orange, is the intersection of the dashed line and the chord, okay? Now, what if I told you that these two, I'll do it in red, these 2 lines are of equal length. That's what it means, okay? Those 2 lines, they've got 2 dashes through them, so this line here and that line there are of equal length. Think back to a previous video. Here, we have a point. We have this line intersecting through that point. The point is on the line, and that point splits this big blue line into 2 smaller blue lines of equal length. That means this grey line is the perpendicular bisector. Okay, perpendicular because they intersect at a right angle, and bisector because it splits the line into 2. That's what bi, oops, can't draw on the circle, that's what bi means. Okay, so we have this line here, and we have this line here of equal length. That means this point here must be the midpoint of the line. We'll put that one on there as well. That must be the midpoint, and it's actually the midpoint not just of the line, of the chord, because we know what the blue line actually is. Okay, so that's all the stuff we need to know, I think, about properties of the chord. Okay, we know the properties of the tangent, radius and tangent meet at 90 degrees, and then we've got some properties about the chord. So let's have a look at 2 examples. The first example is about a circle. We have a circle C, and it's got this equation. X minus 2 squared plus y minus 6 squared is equal to 100. So straight away we can read off what the centre of the circle is and what the radius is. Remember, if we have a centre, and I'll call it CAB, and we have radius R, okay, R is our radius, then we have the equation x minus a squared plus y minus b squared is equal to the radius squared, okay? That's the general equation of a circle, where a and b is your centre and r is your radius, okay? So really from this we can read off exactly what the centre of the circle is and what the radius is, and it's always useful just to get into the habit of doing that. Even if you're not needing it for the question, which I haven't read the question yet, I'm not sure, okay? It's still useful just to do that, to get into practice, so that if you do need it, you don't have to worry. You've done it at the start of the question, write it down. So let's do that. We can clearly see, and we'll do it in green. The centre, and we'll do a better C than that, the centre is going to be at 2, 6, and the radius is going to be 100 is r squared, so the radius must be the positive square root, the radius must be 10. Okay, we'll just highlight that because we might need that for this question. So, let's read on. Part A says verify that the point P, which is at 10, 0, lies on C. Part B then says find an equation for the tangent to C at point P, giving your answer in the form AX plus BY plus C is equal to 0. Okay, so pause and have a go if you want to. To verify a point is on a line or is a point is on a circle, which we have to do here, just substitute the point into the equation and do some rearranging if you can, okay? And then for part B, think about the properties of the tangent here. think about that. Okay, so pause and have a go and press play when you're ready for the answer. Okay, let's see what we can do here. So all I'm going to do is I'm just going to substitute p into the equation. At p, we can clearly see x is 10 and y is 0. Okay, so let's substitute that in, and I'll just write sub. Okay, I'm going to substitute into here, and in fact what I will do is I'll just duplicate that down here. So we're substituting into there. So x is 10, we'll have 10 minus 2 squared plus minus 6 squared, because it's 0 minus 6. That is equal to 100. Well, we don't actually know that yet, okay? So I'm going to put a little question mark, because we're asking, is it true when we substitute the point P into the equation, is it true that the equation works? Can we do some rearranging on the left-hand side here to get 100? And yes, because it's just numbers, okay? So 10 minus 2 is 8. We're squaring that. Minus 6 squared. Is that equal to 100? Again, we'll put a question mark because we're not too sure. Let's do the math. So we've got 64, and then we can just get rid of the negative there because we're squaring. That is then 36. And of course, that does equal to 100. Okay, so P lies on the circle. Okay, we could put a little therefore. Okay, and it's always nice to put a conclusion at the end of your answer. Now, for part B, that's where we need to do a little bit more of the algebra or the maths. Part B said, find an equation for the tangent to C at the point P, giving your answer in the form ax plus by plus c is 0. This is integer form of a straight line, or integer coefficient form, okay? A, b and c must be integers there. And our right-hand side must be 0. So we want the equation of the tangent to C, so the tangent to the circle. We're dealing with this situation here, okay? Tangent at the point P. So let's say, for example, it might not work out if we added some axes on here, but let's just say we have the circle, and this is our point, okay? Point P is 10, 0. Let's say we want to work out, or we do want to work out the equation of this tangent. We know the centre of the circle. The centre of the circle we got from the equation up here. The centre is 2, 6. Okay, so let's put that on. It might not work out. Maybe we should have the tangent up here or something. I don't know, but we'll just put it on. So the centre is 2, 6. Okay. I can quite easily work out the gradient of the radius. And the reason we can do that is because we have 2 points. So I can work out the gradient of the radius. And that is what we will do. Okay, we'll work out the gradient of the radius. So let's do that. And I'll write it here. Gradient of the radius. The reason we're going to do this is because then we can work out the gradient of the tangent, which is what we need to work out the equation, because the radius and the tangent meet at a right angle. So like I said at the start, we can do the negative reciprocal. So the gradient of the radius, we will take C from, we'll take P from C because we've got a 0 here. So I'll do P from C, so we'll have the change in Y is going to be 6 minus 0. That will be on the top, 6 minus 0. Then on the bottom, we will have the change in X, which is 2 minus 10, okay? That's what we'll do for the gradient. That is then going to be 6 over minus 8, which is 3 over, and I'll put the negative on the outside, minus 3 over 4, or minus 3/4, okay? So that's the gradient of the radius. And let's say we call that M, okay? In fact, we won't call it M, we'll call it mg, little subscript g, because in a minute we'll work out what M is. M will be the gradient of the tangent. And to find the gradient of the tangent, I'll write it here. Gradient of the tangent, we'll just take the negative reciprocal of the gradient of the radius because they meet at a right angle. The radius and the tangent meet at a right angle, so take the negative reciprocal. So we can just take that straight away, will be 4/3, and we'll call that m. Okay, and then we can substitute into our equation for a straight line. Okay, the form I'm going to use is this. Y minus y1 is equal to m times x minus x1. Remember, y and x are just fixed. M is the gradient of the line, and then y1 and x1 are the x and y coordinates from just any point on the line. Well, we have a point. We have the tangent to C at the point P. So we know the tangent must pass through P. So we can just use x1 and y1 as the x and y coordinates of P. So substitute that in. Y minus the y coordinate of P, we can see there is 0. So we're just taking off 0 there. M is the gradient of the tangent, which is what we've just worked out, is 4/3. X minus x1 is the x coordinate of the point P, which is 10. So we can take that off there. And then what we need to do is we need to do some rearranging because we want to get it in the integer coefficient form of a straight line. A, B and C must be integers, they're the coefficients, all of those must be integers, and we must have 0 on the right hand side. So we can do some basic algebra to rearrange there. We can multiply everything, or first of all actually, let's write it without the 0, just to stop any confusion, okay? And then all we can do is multiply everything by 3. So we'll get 3y is equal to 4x minus 10, like that, okay? Then let's distribute the 4. So we'll have 3y is equal to 4x minus 40. And then we want the y term second, so we will take the 3y over. We'll have 4x minus 3y minus 40 must be equal to 0, okay? And that is in the correct order and the correct format, if you like, of the answer that it wanted, okay? Also, we could have had all the signs flipped, so that's actually, and I'll write it in green, equal to minus 4x plus 3y plus 40 is equal to 0. We can just multiply everything by minus 1 to get a positive term first, because it's always nice to have a positive term first, okay? So I would say that's the better form of your answer. Okay, so hopefully that makes some sense. All we have to do, work out the gradient of the radius, take the negative reciprocal to work out the gradient of the tangent, and that's always the case. Any question like that, see if you can do that. And then we know the gradient of the tangent, we know a point that the tangent passes through, substitute into this form of a straight line. And we covered this in another lesson. Okay. Let's have a look at the final example for this video, and it's a little bit longer, so let's read it together. It says, the points P and Q lie on a circle with centre C. The point P has coordinates -7, -1, and the point Q has coordinates 3, -5. So we can see, here's our circle. I've just taken this diagram from the book. Here's our circle, there is point P, and there is point Q. It says M is the midpoint of the line segment PQ. We don't really have to write line segment now, we can actually say chord, because it is a line connecting 2 points on the circle together. So that must be a chord, okay? M is the midpoint, and again, we know that because we can see this line passes through C, it passes through the midpoint, and we can clearly see from the diagram that there it is perpendicular. Okay, so this line, or line L that we're calling it, passes through the points M and C. We can see that. That must be a perpendicular bisector. And we'll write that on, actually. Perpendicular bisector of, and I'll say, of chord PQ. Okay, or the line PQ. Okay, so yeah, the line L passes through the points M and C. It should actually say line L there. So first thing we want to do, part A, is we want to find an equation for L. That is quite simple, I think, okay? And then it says, given that the point C, and the point C is the centre of the circle, has an x coordinate of x, we don't know what that is yet, and a y coordinate of -8. B, we want to find the value of x. Okay, so what is the x coordinate of the centre, basically? And part C, we want to find the equation of this circle. So, even if you don't get through all the parts, still pause, even if you just think, don't actually attempt, but have a think, press play, and then we'll work through the answer. Okay, let's see what you were able to do. So for part A, we needed to work out the equation of L. Now, I need a point that L passes through to work out its equation, okay? I can't work out the centre of the circle yet because I don't have enough information. And actually, we do that in part B. And so because it's part B, to work out the centre of the circle, we're probably going to need the equation of L. So let's ignore the centre for the minute. We do, however, know that the line L passes through this point M. And we're told that M is the midpoint of PQ. So let's work out the point M. We will do that first. So M is going to be the midpoint. And to work out the midpoint, remember, we take 2 points on the line, these two endpoints here, P and Q. We will add the x coordinates together and divide by 2. That gives us our x coordinate for the midpoint. And then we will add the y coordinates together, divide by 2. That will give me the y coordinate. Okay, so let's do that. We will have -7 plus 3 over 2, and that will give me our x, and then for our y we will have -1 plus -5, so that's a minus over 2. And when you work out what that is, that will be -4 over 2 and -6 over 2, I think, yes, and that gives me -2 -3. Okay, that is the coordinate of M. And that makes sense because look where M is, okay? We're going -2 in the X, which is there, and -3 is a little bit further down, here, -3 in the Y. That makes sense for point M. So, we now have a point that line L passes through. What more do we need? Well, we then need the gradient of the line to work out its equation. So, what can we do? Going back to the start of this, we can say, or we know from here, we've got a right angle. So we can say, just like with the radius and the tangent, this perpendicular bisector and the chord will have the negative reciprocal gradients of each other. If we can work out the gradient of the chord, we can then work out the gradient of the perpendicular bisector by taking the negative reciprocal. So flipping the fraction and taking the negative. So let's do that. Let's work out the equation, the gradient of the chord first. We have 2 points on the chord, we have P and Q, so we'll work out the gradient of the chord. We'll write that here. Gradient of chord, and it's chord P. Q. So we will do the change in Y and we will take P from Q, I think. So change in Y will be -5 -1. And the change in X will be 3 -7. So that is a plus, I think. Yes, it is. So that is going to give me, I'm sorry, that should be a plus as well. That's going to give me -4 over 10. And we could write that a little bit differently, divide top and bottom by 2, -2/5. So again, what did I do here? I did -5 -1, that's where the plus came from, -5 plus 1, and then divided by the change in X, 3 plus 7. Okay, so we get that. So this is the gradient of the chord. We don't want the gradient of the chord now, we want the gradient of this line L, the perpendicular bisector. So we can just take the negative reciprocal. I'm going to call this M of PQ, and so we will call the gradient of L, we'll call it M, m is going to be the negative reciprocal. So flip the fraction and take the negative. It's already a negative here, so it's going to come positive, and we will get 5/2. That's the gradient that we want to use in y minus y1 is equal to m x minus x1. And we can use that because L is a straight line. So all I'm going to do is substitute this as my equation, or sorry, my gradient, and this as my coordinate on the line L, and we will get a straight line equation for L. So we'll have y minus y1, that's going to give me plus 3, is equal to the gradient, which is 5/2, times x minus, which is going to become a plus 2. Okay, and I'm going to leave it exactly like that because it doesn't ask, I don't think, no, it just says find the equation of L. It doesn't ask for a form of the straight line, so we'll leave it like that. If you want to write it in y equals mx plus c, I think it says it here, it does. We will have y is equal to 5/2 x plus 2, and let's see whether that would have been right. It would. We would have expanded this here. That would have given a 5, minus in 3 will give us a 2. Okay, so either one is actually correct there. It's just that you don't need to do this manipulation because you're not asked to do it. Don't waste time in the exam. Okay, let's have a look at part B. Part B says, given that c is x minus 8, find the value of x. So we know that this line here, because it's the perpendicular bisector, it passes through the centre of the circle. So what we can do is substitute y of minus 8 into the equation of the straight line and work out what the value of x it gives. Okay, so let's do that. Let's sub y equals minus 8 into, and it's actually quite easy to substitute it into there. Okay, so it will be minus 8, we'll write that a bit better, minus 8 is equal to 5/2 x plus 2. Okay, take off the 2 will give me minus 10 is equal to 5/2 x, multiply by 2, minus 20 is equal to 5x, divide by 5, that tells me that x is equal to minus 4. Okay, so that is the value of x. Quite simple there. Part C says find the equation of the circle. So what do we need for the equation of a circle? Remember, it's in this form. I'll write C down here. It's in the form x minus a squared plus y minus b squared is equal to r squared, where the centre is AB and the radius is r. Okay, so what do we need for the equation? Well, we need the centre and we need the radius. We've already got the centre of the circle. The centre is C, and we've just worked out, in fact I'll write it in full, centre of the circle. We know it is the point C, which is at x minus 8, and we've just worked out what x is. It's minus 4. So we know the centre of the circle is minus 4 minus 8. Okay, we just somehow need to work out the radius. Now remember, the radius goes from the centre of the circle to any point on the circumference. We have 2 points on the circumference of the circle. Look here, we have 2 points. We have the point P, and I'll do it in a different colour. We have the point Q. Okay, so we can either do the grey radius or the orange radius. Doesn't matter which one you do. Let's see which one the book does, and I will do the same. It uses point Q. So what I'm going to do is I'm going to work out, this is the radius, I'm going to work out the length of the line Q, or CQ. Okay, we know what C is, we've just worked out, it's minus 4 minus 8. So let's work out that, that length of the line. Okay, so minus 4 minus 8, 3 minus 5. I'll do a little diagram here. This is the centre, minus 4 minus 8, and this was Q, which, where was Q at? It was at 3 minus 5, is that right? Let's just go back. Yes, okay, perfect. So, All we need to do, this is a radius. We need to work out the length of that line, and we can do that using Pythagoras. Okay, we can say, we will take the length of, and I'll write it here actually, length of CQ. Okay, might have to write it down here. It's going to be the square root of, and we will just take the difference in the x's. So we will do 3 minus 4. We will square that, and we will add the difference in the y's. Minus 5 minus 8 squared. That is going to be, and let's see if I can do the maths here. That's going to be 3 plus 4 squared plus minus 5 plus 8 squared. Let's just check that is correct. It is, and when you do that math, put it into a calculator, you get the square root of 58. So this length here, CQ, is the square root of 58. That's what the radius is, the square root of 58. Okay, so that's what the radius is. So in the equation, we need r squared. I'll put that here. That's what the radius is. We'll call it r. So that tells me that r squared is going to be the square root of 58 squared, which is 58. The square root will disappear, okay? And then we've got everything we need to substitute into the general equation of a circle. Nearly said straight line then, of a circle. So we will have x minus a, which is the x coordinate of the centre, minus 4 will give me a positive 4. We'll square that. We will have y minus 8 will give me positive 8, square that, and r squared will be then 58. Okay, and that is your final answer. That is the equation of the circle.